Hi, welcome to QuickInfra. In this video, we will walk you through the various features of QuickInfra. QuickInfra comprises of 4 modules. 1. Infrastructure creation. 2. Setting up of DevOps infrastructure and CI/CD pipelines. 3. Deployment of applications and databases. And 4. Creating a customized landing zone for implementing security, governance, and compliance across multiple AWS accounts. Let us start with a quick demo in which we will create a 3-tier infrastructure and deploy a demo 3-tier Java application with MySQL database. Let's log into QuickInfra. Once we log in, we see a dashboard that displays the details of the CI/CD pipelines, projects, and cloud accounts that we have configured. First, we will add the target cloud account details in which we will be creating the infrastructure. This is the only sensitive data that is captured in QuickInfra, which is encrypted before storing in the database. QuickInfra provides a library of ready-to-use, customizable infrastructure and deployment templates. These templates are solutions to a business use case. Let's say we want to deploy a 3-tier application on cloud. For this, we would need a compatible 3-tier infrastructure. A 3-tier infrastructure consists of 3 layers: the web layer, the application layer, and the database layer. We can pick and choose a suitable infrastructure template according to our requirements. For example, create a 3-tier infrastructure in a single zone or multiple zones, with or without a monitoring dashboard. A multi-zone infrastructure will have additional services like load balancers, auto-scaling groups, and DNS routing for high availability. There are various templates available for setting up the DevOps infrastructure on virtual machines or containers, creating CI/CD pipelines, and for data migration. We can also create our own template or request QuickInfra's 24/7 support team to create a custom template for special use cases. First, we copy a template to create an infrastructure project. I've already copied this template and it's available as an infrastructure project. We can now customize this project by adding, updating, or removing various infrastructure services. For example, if we don't want to create a monitoring server, we can disable it or delete it. If we want to add a load balancer or an auto-scaling group, we can select and add it to the existing projects. Let's modify the web server configuration. Here we can configure the number of instances we want to create, the type of the operating system, Linux or Windows, the type of instances, for example, the number of CPUs and RAM required, in which network and subnet we want to create, and the associated SSH key pair. For operating system, we can select various AMI images like Red Hat, SUSE, Ubuntu, etc. For Amazon Linux, we have this special value, which will install the latest OS available at the time of infrastructure creation. Next, we can select the scripts that we want to execute on the instances once they are up and running for the first time. For example, operating system updates, installing dependencies like Java, Apache, Nginx, Tomcat, etc. These scripts can also be executed on demand using one of the deployment projects. QuickInfra provides a library of all such custom scripts. We can modify or add our own custom scripts and then refer them in our instance configuration. If we want to create instances with a different disk volume size, we can add the details here. If we want to create spot instances instead of on-demand instances, we can add an appropriate spot price which is greater than 0. Finally, we can add additional attributes or parameters to further customize the instances. Sensitive values can be added to Secrets Manager or Secrets Vault and referred here using their keys. Once we have configured this template, we can now generate Terraform. Terraform is an infrastructure as code language. The heart of QuickInfra is the Terraform generation engine. It generates Terraform code dynamically based on the configuration of the infrastructure project. Select the target account in which we want to create the infrastructure. For example, demo account. Generate Terraform. Terraform is generated. We will now execute the Terraform into the target demo account to create the infrastructure. Infrastructure creation has started. It will take a couple of minutes to provision the infrastructure in our target demo account. At the end of this activity, we will have a fully compliant 3-tier infrastructure on cloud as per the recommended best practices of the industry. The infrastructure is now created. Let's check the instance details in AWS portal. We can see the app server, Bastion server, monitoring server, database server, and the web servers created in AWS. Let's check the same in QuickInfra. These are the management screens from which we can manage the infrastructure. We created this infrastructure on AWS in demo account. This was the infrastructure projects that we just created in Mumbai region. Fetch the instance details. We can see all the instance details. From this dashboard, we can start, stop, reboot, delete instances. We can also create instance images and backups of the disk volumes. We can change the hard disk volume size. If it's not encrypted, we can encrypt it. There are various actions that can be performed on the disk volumes. We can create a snapshot or a backup of the disk volume. We can detach, attach, delete, modify, or create a new disk volume. From these management screens, we can manage the various aspects of our cloud infrastructure. As a part of this infrastructure template, we have also created a monitoring server, which is based on open source Prometheus and Grafana. Let us log into the monitoring server. We have provided 4 dashboards out of the box, 2 for monitoring Linux instances, 1 for Windows, and 1 for monitoring log files. The monitoring server has automatically discovered the instances created as part of this infrastructure projects. Here we can see the various instances along with the standard matrices like CPU, RAM, and disk utilization. Now let us check if our web server is up and running. If we see the default homepage of the Tomcat application server, it confirms that all the layers of our 3-tier infrastructure are working fine. We now have a fully modernized infrastructure ready for deployments. QuickInfra provides 2 ways of deployment. 1. On demand. 2. Through typical DevOps approach using CI/CD pipelines. In this demo, we will check on-demand deployments. For deployments, we have various deployment templates for Linux as well as Windows instances. For example, we have deployment templates to do OS updates across multiple servers at scale, do configuration management, copy multiple files, and deploy custom applications like Java, .NET, Python, Angular, Node, React, etc. We have templates for importing and exporting data for various databases like MySQL, Postgres, Oracle, and MS SQL Server. For demo purpose, let us deploy a simple 3-tiered Java application with a MySQL database. Select my SQL database import template. Select the source location where the database script is located. It can be an S3 bucket, FTP server, GitHub, or any accessible location. Enter the URL of the database script and the target location where it will be downloaded. Add the name of the database in which the data will be imported. And finally, the credentials of the database. Ideally, these values will be stored in Secrets Manager, and here we'll refer only to the keys of the secret. Next, select the target infrastructure project and the target account in which we will be creating the database. Connect to it, fetch all the servers, and select all the database servers. For demo purpose, we have created only one database server. We will select that database server. Now, this database is in a private subnet, which is not directly accessible from the internet. To access it, we will jump through a Bastion server. Only this Bastion server can connect to my database server. We will log into this Bastion server and create a tunnel into the database server, download the database script, and import the data. Save the configuration, and generate Ansible script. Ansible is a powerful automation tool for IT configuration management. Script is generated. We will now execute the script. A lot of things are happening behind the scenes. This script will create temporary credentials to download the database script from the source S3 bucket, as it is a private bucket. If the database is not present, it will be created first, and then the data will be imported into this database. Depending on the size of the data, it can take anywhere between a few minutes to a few hours to import the data. Database is now created and data is imported. The next step would be to deploy a Java application. Select the custom application deployment template. Select the source location where we've copied the demo Java application. This is the URL of the demo Java application. This is the target location where it will be downloaded. Once the application is deployed, it will restart the Tomcat service. Select the target project in which we want to deploy the application. Select the target account. Connect to it and fetch all the servers. Select all the application servers. For demo purpose, we have created only one application server, so we will select that. Again, this server is placed in a private subnet, which cannot be accessed directly through the internet. So we will jump through a Bastion server, as only this Bastion server can connect to the application server. We will first log into the Bastion server and create a tunnel into the application server. Then download the Java application, install it, and restart the Tomcat service. Save the configuration. Generate the script. Script is generated. Now we will execute the script. The application is now deployed. Let's check if the application is up and running. The name of the application we deployed was Demo. Yes, it's running. This is a simple 3-tier CRUD application deployed on a 3-tier infrastructure we just created on AWS. Let's say we want to re-import the data again. All we need to do is come back to our database import projects. Select the MySQL database import projects that we had configured earlier and re-execute the script. The data is re-imported again. Now let's go back to the application and refresh the page. And as you can see, the data is back again. The same approach can be used to deploy a new version of the application or database. We just have to point it to the location of the new version. Select the target infrastructure and instances, generate the script, and execute. This is how QuickInfra automates deployment of applications and databases across multiple instances, multiple environments, and multiple accounts. Thanks for watching.